entitled Data and Visualization. And this presentation will be recorded so that either you can access this at a future date or you can share it with colleagues as well. If by chance you did not catch our first presentation, which was on using AI for literature reviews, I recommend that you check that one out as well. For that information, you can contact Emily Rush via email, and she can share that recording with you. All right, so again, welcome. Glad you're here, and welcome back from your holiday break. Hope you had a restful time. Our primary goal for this particular workshop series is going to be to provide you with an overview of currently available AI tools and features as they relate to the research process. And so we want to give you really a mile-high view of what these systems entail, which systems currently exist, and their current capabilities as well. And then we'll also talk about cost, and we'll help you to kind of figure out maybe which of these systems could be worth your time to explore further. So for this workshop, we'll focus solely on using AI for data analysis and data visualization. Again, if you missed our last workshop, please contact Emily and she can get you the recording to that workshop on the literature review process and the use of AI for lit reviews. Okay, so in this session, first we're going to explore 6 different AI tools for quantitative data analysis and visualization. Again, we'll provide you with an overview of these systems' capabilities, and we're also going to summarize their usefulness and their cost. And we're going to do this within the context of 2 cases, or what I like to call these mini experiments, so that you can better appreciate how you might use these systems as a researcher. So that's bullet points 1, 2, and 3. That's all the quantitative analyses. And then the latter portion of the presentation is going to focus on the qualitative research side, and Emily will go through the same process that I used to explain and explore some of the features of qualitative research products using AI. So why might you, or perhaps more likely your students, want to use AI for quantitative data analysis? So here are 3 reasons that I came up with, and this could be appealing to some. Firstly, AI systems allow you to conduct statistical analyses using natural language. So in other words, one no longer needs to know how to navigate statistical software packages, and there's really no longer a need to write any code or syntax for that matter. And so this aspect is what I think students in particular are going to find most appealing, because they don't have to learn a stats system anymore. They can just use natural language to inquiry the AI systems to pull out the outcomes that they're looking for. And then secondly, the data sets don't have to comply with typical formatting nuances. So for those who have used SPSS in the crowd, as you know, all those variables require no spaces, so you have to input underscores or dashes or something, right? So in the case of using these AI systems, those typical formatting nuances aren't required, and you can use, again, the natural language, even within the Excel file, to name your variables. And then I also find some of these AI packages, for stats at least, appealing because it represents a relatively easy way to cross-validate outcomes. And then lastly, I think we'll eventually get to a point where a single AI system is going to be able to do it all. And there will no longer be a need to subscribe to multiple statistical packages to accomplish different end goals. All right, so it's probably where we're headed in the future. We're not there just yet. So I'm purely speculating, but I do think that's where things are heading. So for this talk, we're going to compare 6 AI systems head to head. And again, I'll summarize some of the features of each of these. And at the end, I'll also show you the cost comparison between all of these systems. So the systems we'll explore for today are going to be Microsoft Copilot, ChatGPT Code Interpreter, Claude Sonnet 3.5, Julius AI, PowerDrill, and Notion AI. So to put these systems to the test, I conducted two mini experiments. The first experiment involved both univariate and multivariate statistics. So the univariate statistics that I explored included looking at Cronbach's alpha, a one-way ANOVA, Pearson's correlation, simple linear regression, as well as a multiple linear regression. And for this first experiment, I used SPSS as the baseline comparator. The second experiment was meant to see how well the AI systems could handle meta-analyses. And so I wanted to know things like, could it generate a pooled summary effect size and heterogeneity values, as well as estimates for publication bias. And for that second experiment, I used a system called comprehensive meta-analysis as the baseline comparator. So here's a brief overview of the study that I used to conduct the first mini experiment. The primary goal of this study was to explore how stigmatizing language in patient notes or documents might influence trainees' clinical decisions for patients with substance use disorders. And then secondarily, the same study also investigated how curricula focused on substance use disorder education might affect trainees' attitudes and their clinical decision-making. And so the population of interest was inclusive of 366 medical students from 3 universities. They were from Rush University, Midwestern University, and Loyola University. And of these, 191 of the participants were randomized to the stigmatizing language group, and the others were part of the non-stigmatizing language group. And then there were 3 main variables of interest. The medical condition regard scale was used to gauge participants' attitudes towards their patients based on the language they got, either the stigmatizing or non-stigmatizing language in the patient's document. And then secondly, we also looked at treatment scores, whereby a score of 0 indicated that the student suggested no form of treatment for the fictitious patient, whereas a score of 6 indicated that the student wanted to be most aggressive with their treatment. And then lastly, we also looked at curriculum exposure scores, which was a measure of the amount of exposure that students had related to substance use disorder curricula across their training as medical students. So to develop the prompt, I used the statistical analysis section of the manuscript that I had already written. I mean, we have to write this section anyway, right, for our manuscripts, so why not kind of use it as a guiding framework to also develop the prompt? So notice that in the top half of the slide here, you'll see the original text from the manuscript itself. And then on the bottom half of the slide, you can see that I have modified the text by adding in prompt language. That's the yellow font colored language there. And in addition, I also needed to add in the variable names in green. And as needed, I provided some explanations. So you see that it says variable name equals neutral versus stigmatizing, where 1 is the neutral group and 2 is the stigmatizing group. So when applicable, I went ahead and explained what the variables represented and what those coded values represented. So it really wasn't too terribly hard to generate this prompt. Just took a little bit of massaging with the addition of prompt language and the variables themselves. And then next, I took this prompt and I entered it along with the Excel datasheet into each of the 6 AI systems that were piloted. And by the way, here's what the data set looked like. This is just a screen capture of one small portion of the much larger data set. These data points happen to be the students' individual responses to their attitudes and how they were perceiving the patient based on the stigmatizing or non-stigmatizing language that they received. So all I want to do is just say that this was a very typical data set, and it was one that was formatted already for upload to SPSS. So I'm sure your data sets would look something like this as well. All right, now onto the good stuff. Here are the outcomes for 4 of the 6 AI systems. So the yellow column here represents the baseline comparator, which again was the SPSS stats package system. And all of the green values indicate that the AI system's output was an exact match to the SPSS output. The blue font indicates rounded values. All of the red question marks indicate that the values were not returned based on the initial prompt. So additional prompting was required to more explicitly ask for certain values from some of these systems. So overall, these AI systems are capable of generating accurate outputs for both univariate and multivariate statistics. And as you can see from the screen here, based on the amount of green in each column, Microsoft Copilot and ChatGPT Code Interpreter performed identically, and they returned the highest number of accurate values without additional prompting. Julius AI was awarded 2nd place, and then Claude Sonnet 3.5 I gave 3rd place because it required a lot of additional prompting to get out the values that I was interested in. And again, these are the values that you're most commonly going to report in your manuscripts. All right, and then when it came to the last 2 of the systems, Power Drill and Notion AI, the pilot testing for these was very disappointing, and that's because for Pilot Drill, I reached a maximum token limit for the trial version after the first data run. And then I struggled immensely with Notion AI, and after about 30 minutes, I just gave up. For whatever reason, it would not accept my Excel file or a CSV file, despite saying that it accepts both of these. So I don't know if it had something to do with the trial version and the tokens or what have you, but nonetheless, I was not able to really truly test or pilot these 2 AI systems for use with statistics. In addition to testing the accuracy of the outputs from these AI systems, I also wanted to see how nimble the systems were at including or excluding cases. So as you can see from the prompt on the bottom left of the screen here, I told the system to exclude data from students who answered 3 for any of the 6 curricular elements. And as you know, within SPSS, you can go to and select cases that you want to exclude or include, and that can be done very quickly, right, with just a couple of clicks. So lo and behold, the AI systems were also able to do this accurately, and they were able to return not only the correct number of participants, but of course, based on that correct number, then they, by virtue of that, were able to return the correct statistical values as well that were derived in SPSS. And so this image to the right simply is confirmation that the correct number of participants were in fact included after all the exclusions that I asked it to consider. So it is relatively nimble from a case inclusion-exclusion perspective. Okay, next I tested some data visualization. So I prompted these systems to display the outcomes as clustered bar charts organized by variable. And the variables here were the curriculum score versus the attitude score versus the treatment scores. And then I also wanted it to nest the stigmatizing versus neutral language groups within each variable, and I wanted it to show the error bars. So these are the graphs that were returned. So at first glance, I was fairly satisfied because the graphs had the look and the feel that I was after. So it did a nice job visually. However, when it comes to graphs, I'm very particular usually about the look and feel of the graph. So I like to play around with different colors. I like to play with different bin sizes and fonts, etc., right? And so long story short, there's no easy way to modify these figures without tons and tons of additional prompting. And for me, tons of additional prompting usually leads to frustration. And at a certain point of frustration, I just tend to give up and move on to something else. So, here I wanted to be able to manipulate these graphs in a certain way. but unfortunately, none of the figures could be downloaded as modifiable files. So to show you these images, I had to take a screen capture because I couldn't download them as an image file or as an Excel file or any other modifiable file. All right, so of course that's not ideal because as researchers know, as soon as comments come back from a reviewer, there's probably something that you might need to edit on your graphs. And to edit in this type of an AI system is going to be very challenging and very frustrating. Next, I prompted the systems to show a scatter plot of a Pearson's correlation outcome. And it was correlating the attitude scores against the treatment scores. And I wanted it to also add a linear trend line and to include the line's linear equation. So I would say that Microsoft Copilot and Julius AI generated nice looking plots. You can see they look almost identical here. And I think they're quite usable in the way that they were generated. And then for whatever reason, Claude Sonnet 3.5 and Chat GPT Code Interpreter had a lot of trouble generating these fairly basic plots in my mind. So why some systems could generate them versus others is an unknown. And I can't really explain why these systems had so many problems with generating a simple Pearson's correlation plot. So I think the long story short here is that, as you're starting to see, no one system has a perfect track record for doing everything that I wanted it to do. Some of these systems were really hit or miss at times, and no single system was perfect by any means. Okay, here is the second mini experiment. So for this iteration of testing, I wanted to know how well the same AI systems could handle meta-analyses. And so the prompt, as you see on the screen here, was asking for common statistical outputs for a meta-analysis, such as a pooled effect size with confidence intervals, as well as heterogeneity values, and then also an indication of whether or not publication bias was likely to be present. And again, this is the exact prompt that I used on the screen. Again, I stole this from the statistical analysis section that I had already written and just massaged it a little bit to make it more prompt-esque, if you will. This time, I used comprehensive meta-analysis as the baseline comparator. And as you can see, the outcomes here are very different from the outcomes that were revealed on the univariate versus multivariate analyses. So basically, all the red font here again indicates that these AI systems were not able to return exact same values that comprehensive meta-analysis generated. Again, the blue indicates rounded values, and the green are identical values. So you might notice that Chat GPT Code Interpreter here returned the closest values to the comparator system. However, I just didn't feel like I could really trust Code Interpreter because it especially kind of goofed up the publication bias component, etc. So presently, in good faith, I cannot recommend any of these AI systems just yet for conducting meta-analyses in particular. So even though Claude Sonnet 3.5 did not have great outcomes because they were not identical matches to comprehensive meta-analysis, what it was able to do very nicely was it returned a really beautiful results write-up section for the meta-analysis data. So this write-up was pretty much, manuscript ready with only some minor editing required. And you can notice here that in these yellow highlighted sections, so the top section here, for example, it even goes into the detail of how to interpret an I-squared value for heterogeneity and what that means. And then much to my surprise, in the second box, it was able to explain that there were not enough studies to conduct publication bias estimates, which I fully agree with. That is a true statement. but none of the other systems picked up on this, whereas Claude Sonnet 3.5 was able to pick up on that key notion and was also able to write it into the results section that it generated as its output. So as far as write-up goes, I will give Claude Sonnet 3.5 a gold star. All right, but again, on the stats side, it wasn't as great, not as robust. So again, now we're in this scenario where we've got some great systems that are crunching the numbers really well, but then these other systems are maybe better at the results write-up component. On the left of the screen is the forest plot that was generated by comprehensive meta-analysis. Again, that was our baseline kind of gold standard. And then to the right, you see the forest plots generated by Julius AI and by Claude Sonnet 3.5. Of course, of these two, Claude Sonnet 3.5 is by far better than Julius AI, and it's the one that's closest in comparability to comprehensive meta-analysis. Right? But again, I have to say that there was no mechanism to save any of these files in a user-friendly format. So hopefully future updates will resolve that particular issue. Okay, here's a snapshot of the cost breakdown for each of these 6 AI systems. And again, overall, I cannot recommend PowerDrill or Notion AI simply because I was not able to do enough pilot testing on these systems to give you useful information. So as you can see from a price point perspective, Microsoft Copilot is $30 a month, and then the lowest value would be Julius AI at $17.99 per month. So they're all within a $15 range or so of one another. All right, so let me just briefly summarize the section on quantitative data analysis, and then I'll hand the presentation over to Emily, who will tackle the qualitative component next. So in summary, no single AI system can do it all yet, but I, again, do think that the day is coming when one system will dominate, but that has yet to be seen. So what are the key takeaways? So here's some key points regarding the pros. These systems were able to generate useful outcomes that were mostly accurate for some of the systems. The systems were easy to interact with because of the natural language component, and they were able to read and process Excel files in natural language as well. And they could also select cases by either including certain cases or excluding them. And in the case of Claude Sonnet 3.5, it was able to return a nice and robust results write-up. And then lastly, I do think these systems could be used to double check one's work against standard statistical packages. So all of those I would couch as being the pros for these mini experiments that I ran. Regarding the cons, some of the systems were really hit or miss. Sometimes they were able to generate the plots and other times they weren't. Sometimes they were able to generate the exact values compared to the baseline gold standard comparator, and other times they weren't. So again, a lot of hit or miss between the systems. And then some systems did not fully execute the prompt upon the initial request. So I did have listed in the prompt that I wanted a results write-up on the output, but a lot of the systems just kind of ignored that component and required you to input another prompt to ask for that again before it would yield a write-up, for example. And then I think the biggest limitation of these systems right now is on the data visualization side, because you could not generate really the graphs that you wanted in the way that you wanted because the files were not modifiable, etc. So until the files become easier to edit, I don't necessarily recommend using these AI systems for data visualization purposes. Okay, so that concludes my section, but before we go on to Emily's section, I would like to entertain questions for those in the audience. So I'm going to pause here, and please, if you could either input your question into the chat. And Emily, if I could ask you to read those because I'm navigating multiple screens, and or you can, of course, unmute yourself as well, and we can just communicate. So what questions do you have?
It looks like Rick has a question.
Go ahead, Rick.
Yeah, I'm just down the hall from you, Adam. So I could walk over and bug you, but I won't. So I actually on the data visualization, at least I found that interesting. Like you could say, give me a nested plot. So assuming the data were plotted correctly and the error bars were roughly correct, I would almost be more inclined to use that than anything else because a lot of times just taking a quick look at the data plotted that way is extremely helpful and then almost informs on, well, how should I even do the analysis? And then I'll worry about using an actual package to plot it, later when I could modify it. So even though it couldn't give you like publication ready figures for a really quick look at the data, that seemed almost better than anything else I saw.
Yeah, I think that's a fair statement. So, and you know me really well at this point, Rick. So you know that I'm very efficient in much of what I do, and so I like to kind of double up things when I can, right, and try to produce the closest to the end quality product as possible early on. And so from just a kind of pilot perspective and getting a visual of the data, I absolutely agree. It's a quick, easy, dirty way to do that. But if you're looking for it to also be your final end product, it's just not going to get you there. So it really depends on your end goals and how you want to use that particular information.
Thanks.
I have a question.
I don't know if Chris has any questions because he's got his camera on, but I'll ask a couple. Great job, Adam, there. Were you actually using all the AI softwares in their pro version, or some of them were free?
The systems I were using were all the free versions because I do not have a paid account. So for ChatGPT, it was the no, I'm sorry. I said that wrong. I forgot that Emily helped me with this. So what we did is we got on Zoom, and Emily has purchased the code interpreter, for example, which is the paid version. And so I gave her the prompts, and she ran all the prompts for me. For Julius AI, that was just the free trial version. Same with Power Drill, same with Notion AI. Emily, did we use any other paid versions? Because I think Claude may have been paid as well from
Yes, we
your
use
account.
the premium Claude as well.
Yep.
So in other words, your comparison of ranking them and all that is maybe not as accurate if they were all pro or all free.
Well, I would have assumed that it depends on how the trial version is set up, right? Some trial versions will give you full access for a short, limited time frame, just so you can see what the systems are capable of. Others, of course, will limit its features as well. I don't know if Julius AI had limited its features and thus was not returning the values in the trial version, or if I was really seeing the full package, if you will. So that's a bit of an unknown that I can't answer.
So do these packages actually tell you what stats package they are using in the background, or it's all black box?
A little bit of black box. It's using Python for a lot of its scripting and such. Emily, were we able to discern which packages they were using? I think it may have been R, but I don't want to say that outright.
I'm not certain. You're correct that Claude uses JavaScript and ChatGPT uses Python, but I don't know about the rest.
Yes.
Okay. Final question. Just a comment more like actually. Since you could do it so easily, so quickly, I wonder if going ahead, journals are going to be asking authors to submit their raw data so they can put it through their own mill of these AIs and make sure that what you're saying is accurate.
Possibly. I think a lot of changes are coming to the world of academic publishing, not just submission of possible data sets, but also maybe even AI being the first pass reviewer, right? So I think the sky is sort of the limit right now for what some of these things can do and what the future might entail.
Thanks.
Hi,
Hey, Adam, I think
question.
you have a question in the chat.
Yeah, that is from me. So I ask you about you are the associate editor for a journal. So I just wondering, does your journal have any requirement on the use of AI for data analysis? Same as me, I'm the section editor for a respiratory care journal. We're also concerned. Our journal have much discussion about it, so we are much concerned about the leaking on the data. Do you have any concern on that, especially if this data set contain? I mean, it's all de-identified data, but does this allow for us to upload to ChatGPT for analyze patient data? Do we need to inform or get approval from IRB, etc.? Do you have any comments on that?
Yeah, so our cybersecurity team at Rush is kind of exploring some of these questions as well, right? And in the case of Rush, of course, for patient-focused data and this student data that I presented before you today, we of course have to get IRB approval. And now, evidently, the cybersecurity team is getting a lot of the IRBs that are disclosing the use of AI so that they can check the AI component of it. So our cybersecurity team is really acting as consultants for the IRB process currently. It's kind of tricky though, because you don't always know in advance if you're going to run some of these data through an AI system or to what extent you're going to use AI on the back end, et cetera, right? So do I think that patient data needs to be protected in the AI world? Absolutely. And so at Rush, right now, the only approved system for use is Microsoft Copilot because of all the extra security that it has for patient-facing data. The data that I used here for the pilots, of course, were all de-identified, so there was no risk for leaking any student information in this case. In the case of the journal that I work for, we do not have any requirements. It's really the wild, wild west still when it comes to the publishing landscape, and it's highly dependent upon the publisher themselves. So the journal that I'm with publishes through Wiley. Of course, Elsevier has perhaps different stipulations than Springer, et cetera. In the case of our journal, we only require that there be some sort of acknowledgement that artificial intelligence was used and how it was used and the extent to which it was used. But that's really, it's just a disclaimer at that point, and there's really no additional checks or balances that are done. And it's really becoming, again, another sticky point because a lot of the classic systems that I have used as a researcher, for example, I do a lot of systematic reviews and meta-analyses, and I use Covenants, for example, which our library has a subscription to. And Covenants has now, within its system, integrated in an AI component that will help to sort all of the records so that when you're doing the inclusion and exclusion screening process, it's much more efficient, right? Well, that was a system that was kind of the gold standard. So now it's a question of, well, do I still have to disclose that that's AI use? Because it's just embedded into the system now. And even though it tells me that it's using AI, I don't actually know exactly what the AI is doing or how it's doing it. I'm just trusting it at this point, right? So I think we're getting close to a day where many of these systems will have AI embedded into it. And whether or not we'll have to disclose is going to depend upon how the language is written for each journal, et cetera. So I know I'm kind of floundering here in my response. I don't have a good answer for you, but I think if you ask that question of any individual at this point, they're probably not going to have a perfect answer either.
Adam, I have a couple questions. Do you think the response from journals today is going to differ very much as compared to, let's say, in a year or 5 years from now? I guess I'll answer my own question and say I think it'll be very different as we all kind of grapple with this and as the technology evolves and as it evolves and gets integrated within these other programs. I assume some of these processes will kind of work themselves out, right? Where when we cite a program, we kind of know that program is using AI in the background, right?
Right, and I think we'll come to a point where it's no different than citing SPSS in a manuscript or Excel in a manuscript. We have come to a point where we now trust those systems and they are, common practice. So I think we'll get to a point as well where whatever AI system we're using, there may be some that are the trusted systems and are sort of approved, if you will, and maybe those that need additional validity testing, et cetera. So it is really important work in my mind to do the reliability and validity testing of these AI systems as they're coming online, so that we can have at least some confidence in the outputs that they're generating. So if you haven't yourself kind of done some of these mini experiments like I'm doing, I would encourage you to do some of those, especially for newer systems that perhaps we haven't covered in this particular talk.
Another question. So obviously you had to choose. I missed a little of your methods, but I assume you kept the input to all the systems roughly the same. I think you had it coded in a specific way.
Yeah, the prompt was identical for all 6 systems, if that's what you're asking.
Yeah. Do you think, or maybe you tried this, I don't know. Do you think if you changed the prompt slightly, that different systems would handle that change differently and the output would have been different? It just, your prompt may have been just more friendly to one system than the other. And if you had just even tweaked, ever so slightly tweaked it, you could have gotten a very different response, showing that there's still a lot of user, not bias, but the user plays a major factor in working with the system.
Yes, I definitely think that is a possibility, and I think Emily would agree that the prompt is sort of the end all be all, right? If you have a poor prompt, you're going to get a poor output. So garbage in is garbage out. In this case, I put together the prompt in a way that I felt like all the information that I wanted to see would be present, right? Or if I was telling another researcher, here's what I need from my data analyses, like a statistician, here's what I want out of it. This is what I would expect. And that's kind of how I structured my prompt. So the fact that I would have had to write more elaborate prompts for some systems is, in my mind, a con, right? Because I don't want to spend necessarily a lot of that extra time trying to figure out exactly how to prompt the system to get the answers that I'm looking for. I really want it to be as user-friendly as possible, as efficient as possible, et cetera. And so I feel like through the mini experiments that I ran, the 2 systems that were the most user-friendly based on my style of writing, I guess one could say, would be the Copilot and then the code interpreter.
Sorry, I have another question about teaching the students on statistical analysis. Do you think in the future, should we teach differently on statistical analysis for the student using AI?
So I think it depends on the student population, of course. You're going to want your graduate students to still know how to use R and SPSS, et cetera, and SAS. But in the case of medical students who are on a summer research fellowship, for example, they're probably not going to have the time to go in and learn how to navigate SPSS or other packages. But they might be armed with enough knowledge to know what statistics they're after and how to get those outputs from the AI systems. So I think it's certainly worthwhile to again, kind of use this process as a cross-check mechanism, right? So if I have a student over the summer, I'm going to tell the student, hey, go in and run these stats through Copilot, let's say, and see what you get. And then I'm going to compare them with my SPSS that I get on my end, right? So you do it that way and I'll do it this way. And it gives the student, a good experience, I think, to use these systems. And then hopefully at least they'll know, or have a baseline level of knowledge of why they're running the statistics and the types of outputs that they're getting and the interpretations of those outputs. But of course, if you don't kind of understand the very basics of statistical approaches, then you're just not going to know which stats to run, right? So there has to be certainly a baseline knowledge that they have to work with to even start somewhere.
Good points and good suggestions. Thank you.
All right, so I don't want to take up too much more time with questions because Emily also has some components to share in regards to the quantitative analysis. So I'm sorry, qualitative, not quantitative. So I'll turn it over to Emily for the qualitative analysis, and data visualization.
All right, thanks, Adam. Okay, so welcome everyone, and to the second path or the latter portion of the workshop, in which I'm going to provide an overview of some of the AI systems that I explored for qualitative analysis and data visualization. On the screen are the 6 systems that I explored. So Analyze, ChatGPT's code interpreter, Claude Sonnet, Atlas TI, Atlas Binomic, and NVivo. And just for the sake of transparency, I didn't get very far with NVivo. I was unable to download software to my Rush computer, and additionally, the AI component for NVivo does not have a free trial, and it was rather cost prohibitive. So as we move to the next slide, I'll tell you about the next few systems that I explored. But before I do that, I'm just going to tell you about some of the potential benefits of why one might consider using AI for qualitative analysis. In my experience, I found that using different AI systems might be helpful for sort of exploratory scanning for large documents or data sets, in the sense that it could help the user identify preliminary patterns in the data or areas for further analysis. It could potentially assist with content categorization by locating broad themes and perhaps providing a starting point for additional research. And then finally, one of the areas in which AI, I guess, was especially proficient or more proficient in this area was for sentiment mapping, or for looking at patterns in documents in terms of language, tone, or document characteristics. Next slide, please. All right, so what I'm going to do is first tell you a little bit about the mini experiment that I used, and then I'll walk you through some of my actual experiments with different AI systems regarding this particular data set. So for my experiment, I used as its basis a work in progress, which is the examination of artificial intelligence policies across US medical schools in comparison to an idealized AI policy framework, which you can see sort of the skeleton for that on the left. That's a screenshot from the policy analysis framework that we're currently using in Deduce. And I should note that this is a collaborative project in which I'm working with Adam, as well as a variety of researchers from Rush and outside of Rush as well. Currently, we're looking at documents from approximately 150 medical schools in terms of the nature and the coverage of AI policies. And we're looking at things like the scope and the degree to which it addresses different aspects of AI policy. What are some implementation guidelines? How does it address ethical considerations and other aspects like instructional technology and support? So using that as its basis, my goal was to then apply the data set in different AI systems and see how well it could help me analyze this project. So the first experiment I did was using a tool called Analyze. And I began with uploading the whole data set, which is something that not all the systems that I explored could do because it was a rather large data set. The policies themselves are about 135,000 words, so a large data set. And after uploading the full data set, Analyze gives you the option to choose one of 3 types of analysis. So in this case, I conducted a thematic analysis based on the text in a specific row, and it was able to conduct a high-level analysis of that data set and returned 5 high-level themes that were relevant to our AI policy analysis. And you can see those on the lower left, starting with academic integrity, ethical use of AI tools, and so on. That said, although it could conduct a very high-level analysis of the AI policies, there wasn't a way for me to apply the more detailed AI policy analysis framework that you saw on the previous slide. Okay, in addition to that, I also conducted a secondary analysis with this tool in order to identify characteristics of this particular data set, labeling each policy as permissive, conditional, or restrictive. And again, the tool could perform the analysis. However, it was unable to apply one label to every policy. So what that means is it applied multiple labels to each policy despite my prompting for it to do otherwise. Okay, the next slide, please. All right, the next tool I tried was Atlas TI, which initially looked rather promising. So again, I could upload the entire data set and enter high-level themes for analysis, which you can see on the left, it turned these themes into questions. Then I waited about 23 minutes for the tool to process, and it timed out 3 times. And so I gave up at that point with that kind of thematic analysis. From there, I was able to conduct a rather rudimentary sentiment analysis by asking the system to characterize portions of the text. And it did this by characterizing them as positive, neutral, or negative. It could successfully do this kind of sentiment analysis, but the reasoning for the characterization was rather opaque. So for example, there was no way to determine from the system why faculty having the ability to set expectations regarding AI in their class is negative, whereas other aspects were positive. All right, next slide, please. Okay, so frustrated with those earlier attempts, I then tried a different strategy using ChatGPT. And what you can see here is I prepared a somewhat elaborative prompt that you can see on the left. And the most salient points are the portions in red. So basically, I asked ChatGPT's code interpreter to perform a qualitative analysis with the goal of also producing a visualization. And in so doing, I asked it to score every sub-theme in that initial idealized AI policy framework. So it's about 6 themes with multiple sub-themes. And I could enter that into ChatGPT, and I asked it to assign a numeric score for the presence or absence of each theme. 0 being that sub-theme wasn't mentioned at all. 1, it was mentioned in passing at least. And 2, moderate detail, 3, in-depth detail. So I put this prompt into ChatGPT, uploaded the entire data set, and then it did score the entire data set, but it awarded 0 to every single sub-theme, indicating that it was unable to recognize the prevalence of any of the sub-themes in the data set. So again, this suggests that ChatGPT was looking more for word matches and didn't really have the semantic flexibility for the kind of analysis that we're doing manually with deduce. All right, one more experiment. Thanks, Adam. All right, so in a final experiment, I asked ChatGPT and Claude to rate the coverage of the 6 broad themes that you see at the top of the screen in bold, and rate them on a score of 1 to 5 in terms of their prevalence within the data set that I uploaded. Now, both systems were able to apply the rating scheme. ChatGPT could do this for the entire data set of 147 schools, whereas Claude has a smaller context window, so I could only upload about 45 policies at a time. And so what you see here is, of course, a very small selection from this experiment. I want to add that there is no human baseline for this experiment, so I can't speak at all to the validity of this particular approach. But each system was able to score or apply the ratings that you see. You can also see that there was significant variation between the two systems, so Claude across the board seemed to award higher scores. Just sort of my thoughts in terms of these approaches is that it suggests to me that systems like ChatGPT and Claude might be more effective for mixed methods approaches rather than the kind of qualitative analysis represented by the AI Policies project. Next slide, please. All right, and just to round out my discussion in terms of data visualization, which was a bit lackluster, rather like some of my other experiments. So just to note that a few of the tools, Atlas and analyses that I piloted, did not have data visualization capabilities. ChatGPT and Claude both do have data visualization capabilities. However, ChatGPT was unable to render any visualizations that were relevant to my experiment. Claude could render visualizations, but they were so unhelpful that I decided to not even share them today. And then Atlas Binomic also can render visualizations, but again, they were unhelpful to the particular project that I'm undertaking at this time. Okay, next slide, please. Just to round out in terms of the costs, they range in cost. iLies is somewhat expensive at $50 a month. We've already seen the cost for ChatGPT and Claude Sonnet, both $20. And then the other systems range anywhere between $26 and $10 to NVivo, which, as I said, I couldn't pilot, but its AI feature costs $250 a year. And the systems on the right, I really just couldn't experiment with them enough to recommend them at this time. Okay, and I think we have a few minutes if there are any questions. Yeah, that's a great comment, is the comment about being worried about newer generations of scientists using all this material, not knowing whether it's correct. I think that's a valid concern. And I can't tell you the number of influencers on social media who are trying to get young researchers to use these tools, perhaps without thinking about the implications of their use.
I feel that there is no risk in sort of advancing and using new tools as long as we know, the limitations and where we actually, what are we actually doing? As I was asking Adam before, is this all a black box? It's a bit like that as well when you're using SPSS, you're trusting it, but that trust is verified. We are still going through the process here of verification.
I think certainly there's that element, and then also we want to be careful to protect our intellectual property also when we're using those systems and thinking about the steps that we take to mitigate IP concerns. All right, well, I'm happy to take more questions, or I love seeing your comments. As you're thinking of those, I just wanted to take a moment to promote some upcoming events. So our third workshop in this series is coming up on January 21st, in which we will explore AI as a first peer reviewer, and we'll discuss some of the ways that you or your students might benefit from this kind of AI formative feedback. I also wanted to take a moment to promote the next AI Learning Community meeting. If you're not familiar with the AI Learning Community, it's a faculty and staff community of practice focused on AI use at Rush. Our next meeting is actually December 6th. We're meeting on Friday, not Saturday, from 12 to 1 p.m. If you're interested in being part of that community, feel free to reach out to me and I will forward the invite to you and add you to our mailing list. And lastly, before you leave the call today, I just want to put our post-workshop survey in the chat. We welcome your input regarding today's workshop and suggestions regarding future workshops. So thank you so much, everyone, for joining us. And thanks again, Adam, for leading this workshop.
If you want to ask other questions, we're happy to stick around as well, but we're close to the noon hour. So again, thank you so much for being here.
Thanks a lot.
Sorry, so for one more question, So, do you plan to publish your result on this small experiment?
Not at this point in time. This is really just kind of done for our own gratification to figure out what these systems were capable of and to share our thoughts and experiences with our own faculty here at Rush. So, yeah, perhaps it could be massaged into some sort of commentary or something, but not at this point.
Yeah, but I really like the Emily's portion about the, the qualitative analysis on the AI policies, because we, like what I mentioned earlier, as our journal, the section editor for our journal, we're interested to know, what's the current policy among different universities, even journals, about their AI, about their policy on how to use AI. So I think really this is worthwhile to publish, I think.
Yeah, so that particular project is
Yeah.
currently underway, and we're in the data analysis phase of that. That will absolutely be published. I thought you were referring to these mini experiments we had done.
No. The Emily's portion about the qualitative analysis. If you can add some of the, portion on, let's say, the journal's policy on using AI, that would be more helpful. Then you have two components. One is on the university and the policies. Another one is the journal policies. So that would be great. Would be very helpful, I think.
Yep, we're working on it, but it's a slow process. There's a lot of data to pour through.
All right. Good job overall. Thank you.
I have a small comment. Thank you, first of all, Emily and Adam. This was very helpful. Just to plug, next Tuesday, there is a Provost Series talk, and Dr. Berger Wolf from Ohio State will be talking on AI for Good. That's the title of her talk. I don't think she'll get as much into the details of using it for academics, just as this talk, but it may be helpful for those who are interested in more general AI issues and using it for research.
Yeah, that's great. Thank you for sharing that.
Yeah, I think it's Tuesday at 1 o'clock.
Okay. All right. Thanks again, everyone, for your
Thank
time.
you.
Take care.